Hi everyone, so me myself, Medinna Rasha, will act as a physician in this video, and this time I will be explaining about wave interaction. So the outcome of the last topic for physics is wave and sound, and it is able to implement phenomena of waves and light in a physical and geometrical optics phenomenon to provide a future forward innovation. And speaking of which, we have a big question for the semester, which is why might visionary leadership cause and or effect transformation? Which at the end of the video, I will be explaining the correlation between the outcome to the big question. So moving on to wave interaction. The first one that I picked is reflection, which is when a wave strikes an object or surface and it bounces off at a boundary. And the reflected wave is exactly like the incident wave in terms of amplitude or the height of the wave itself. Reflection on a smooth surface. The reflection will be clean and sharp, so it will kind of be clearer to see than if it is on a rough surface, because the reflection will be distorted and the light will scatter, making the reflection not as visible as if it is being reflected on a smooth surface. And then there are two types of boundaries in reflection. At a fixed boundary, the wave reflects but turns upside down, which I will be explaining later. And also at a free boundary, the wave reflects with no change of amplitude, unlike the fixed boundary. So right here, and this one is more of a graph of how a reflection works in a surface. On the left side, which is incident ray, which comes in towards the surface, while the reflected ray will kind of come out. So the incident ray comes down while the reflected ray comes up, showing the reflected version of from the incident ray. And then on the picture on the right, for point A, which is free end, it is the free boundary. If it is being bumped into a boundary, the wave will go towards the boundary, but it will just bounce back with the wave not being under, just like the fixed boundary. So fixed boundary is basically the opposite of the free boundary. The fixed boundary, when it bounces off the boundary, it will switch and the amplitude will kind of become on the bottom and it will become so on. It will go on like that. And then an example is you can see in the figure one, which is reflections from the surface of water. The waves encounter a surface The waves encounter surface or other boundary that does not absorb the energy or the radiation and bounces the waves away from the surface. So on the left side of the picture, you can see the reflection of the mountain on a water surface that is more smooth and still, therefore making it clearer for humans to see. And overall, there's no patterns of the reflected light. But on the other hand, on the picture on the right side, because the water is not as still, it makes the mountains look more not as visible because of the light reflection being scattered because it is being reflected towards a rough surface. And then moving on, we're going to be talking about interference, which is the two or more waves meet while traveling in the same medium, or its overlapping waves. There are two types, which is constructive interference, which is crest overlap with crest. The second one is reflective interference, which is crest overlap drop. There are two types for the constructive. The waves bump into each other and have higher amplitude in a certain point and disruptive, the waves meet in the equilibrium line, making a straight line, and create a smaller amplitude or crest, cancel crest, with the crest and crest have same amplitude. So right here on the constrictor interference, there are two crests and they kind of bump into each other, making the middle part kind of make a bigger wave and double in amplitude, and then it just goes back like how it was before, but going to separate waves. And then for the shortest interference, it comes from two different sides, one on the top and one on the bottom, and then they bump into each other and they meet and making a straight or uh, equilibrium line, and then they bounces off with switching the side. So the one that was upwards becomes downwards, and the one that was downwards becomes upwards. An example is by producing a sound wave that is 180 degrees out of phase with the noise cancelling that switch to block out, but noise cancelling headphones block out unnecessary sound. Sound waves essentially cancel each other, but when one is at its highest peak and the other is at its lowest. And the example is on the right. The pink waves show sound waves by headphone speakers, and the blue shows ambient sound waves, which is the noise. And because they meet in a straight line, it becomes equilibrium, so the unwanted sound is cancelled out. Therefore, my answer to the question is waves are caused by disturbance or vibration that travels and carries energy from one point to another. It is created by oscillation or vibration of the medium through which they travel. They give an effect towards our daily life, just like that has been stated in the video, especially in water or mirrors or experience in noise cancelling headphones. Thank you.